Friends, once again into VK Jain Sarki MEP classes. Now I am presenting module 2 L2, which is theory of illumination. Friends, I am dictating the theory of illumination, the science of measurement of the energy of radiation, an objective quantity that can be measured in watt is called radiometry. When the special sensitivity to eye is taken into account, the measurement is called photometry, where light is measured in lumens. Photometry is semi-objective intermediate between the physical stimulus of energy and the psychological response of brightness. Although we often say eye, the visual sense is actually located in the brain. The eye is merely a sensor. Uh, the eye is sensitive to different type of illuminances, which are measured in lux. I'll define in the next slide what is lux. On summer midday, we have about 1 lakh lux of illumination, and that reduces in winter midway to 10,000 only. It gets reduced sharply during full moon, either in summer or winter. It is something like 0.25 lux, and during dawn and dusk it is approximately 300 lux, and for office general illumination purpose we have to get illumination level up to 300 to 500 lux, 500 for drawing purposes. Uh, Friends, now we are talking of luminous flux denoted by F. The light rays emit from any source in all directions universally if the source is unobstructed. Total quantity of radiations, that is light emitted by a source of light in all directions in any unit time, is called luminous flux. It is rate of emission of radiations, luminous flux. Luminous flux emitted per second is defined as 1 lumen. Now, in this diagram, we are getting natural light from sun, which is radiated in all the direction, and this is the cone of light of radiation, light radiation. Luminous flux as needed in lighting services. Luminous flux is the electromagnetic power in visible range falling in particular direction. We have read in another module, denoted by FV and measured in lumen. The CIE defines the lumen in terms of luminous flux of monochromatic radiation of at 555 nanometer wavelength. The symbol of luminous flux is F, or phi in Latin. Illuminance is the measure of photometric flux per unit area or visible flux density. Illuminance is measured in either lux, that is lumen per meter square, or previously it was being measured in foot candles, lumen per feet square. The formula for luminous flux is E is equal to phi divided by area. This area is incident area and E is illumination in lux and phi is flux in lumens. Friends, will once again define illumination level, which is also known as illuminance. The luminous flux falling on a surface unit area is called illumination level or illuminance, of which unit is lux. If 1 lumen of luminous flux falls on 1 square meter area, the illumination level produced is equivalent to 1 lux. Previously, it was expressed as foot candle, that is equal to lumen per square feet, which is equal to 10.76 lux or 1 lux, equal to 0.093 lumen per square feet, that is foot candles. Normally, the intensity of illumination is not same in all directions. Therefore, average illumination is the term used for measurement of light energy, which is equal to total amount of luminous flux falling on some object divided by the area. That means E average equal to flux divided by area. This F is luminous flux. There is another agency, international level, which is known as ESNA, Europe Startup Nations Alliance, and they have given their recommendations about illumination level or illuminance. As per them, public spaces should have 30 lux. Simple or orientation for short visit 50 lux. Simple visual task 100 lux. High contrast and large size 300 lux. High contrast and small size 500 lux in case of drawings. Low contrast and small size 1000 lux. Special visual task may be around 3000 to 10,000 lux. Friends, now we are talking of vision. The vision normally are of two types, photopic and scotopic. Photopic during daytime and scotopic during night. But there is a region known as mesopic vision, as shown in green color here. So this diagram shows luminous efficiency functions of vision. Huh? And this graph shows is based on wavelength in nanometer. The light region from 380 nanometer to 780, and all the three different photopic, scotopic and mesopic are shown here. Friends, a little of mathematics of 3D geometry. There is something like solid angle, of which unit is steradian, denoted by SR. A solid angle is three-dimensional angle subtended at a point by the surface or object. say this is spherical area, and we are talking of one unit state radiation area, which I have shown here also. So this is known as omega equal to area divided by square square meter of radius, where omega is solid angle, a area cut out on a sphere, this area, r is the radius of a sphere. Friends, here we are discussing one more uh, lighting definition, which is known as luminous intensity. Luminous intensity is the amount of luminous flux in lumens produced by a point source in a given specific direction, measured per unit solid angle in steradian. The unit of luminous intensity is candela, which is SI base unit. Now, let me tell you that previously we had been using FPS, foot pound second system. Then we used MKS systems. But currently in all Indian specifications, the Bureau of Indian Standard is using only SI base unit, which is the right type of unit. Uh, the luminous intensity is directional in nature. Unlike luminous flux, IV, IV measures how bright a light source appears. So luminous intensity is all about the brightness of the source, not the object. Formula is IV equal to 5V divided by omega, where omega V is, is in lumens, the 5V is in lumens, and omega is solid angle in steradians. Application. It is the primary metric for specifying the brightness of LED lamps or any other lamps, and displays particularly when light is concentrated in a specific direction. Once again, into concept of luminous intensity. I have shown a source of light, and luminous intensity is the fundamental SI quantity for photometry. Luminous intensity is the amount of visible power per unit, this is per unit solid angle, measured in candelas. The candela is the fundamental unit from which all other photometric units are derived. So you can see this goes on in one unit angle, solid angle, the source getting source as seen from a distance gives you luminous intensity, shows the luminous intensity on surface of this source. Friends, I am discussing one of the universal inverse square law. I told it universal because most of the energy formations obey this type of law. Light is one of them in form of illumination. Gravitational force is another which follows this law. Electrostatic force also follows this law. Sound vibrations approximately follow this rule, but not the magnetic energy in any form. As a surface that is illuminated by a light source moves away from the light source, the surface appears dimmer. In fact, it becomes dimmer much faster than it moves away from the source. The inverse square law, which quantifies this effect, relates illuminance and intensity LV as follows. EV is equal to LV divided by distance between the two places where they are getting measured, where d is the distance from the light source. For example, the luminance of a surface is 40 lux at a distance of 0.5 meter from the light source. The illuminance increases to 10 lux at a distance of 1 meter as shown in the figure. So this is the area at different angles, and this area and sorry this area and this area and the other area, they are at distance of 1 meter, 2 meter and 3 meter, and the intensity is 1 lux, 1 quarter lux and 1 ninth lux. It is here the intensity has diminished to this area, 1 1 by 9 lux as compared to 1 1 by 4 on this area as compared to 1 square meter this area. So it is inversely proportional. Friends, the various features of two definitions, luminance, that is lighting level, and luminance, that is brightness level, are compared. Measures falling light, emitted or reflected light. Unit, here it is lux, that is lumen per square meter. Here it is candela per square meter, known as NIT. Instrument through which these are measured, lux meter, luminance meter. The depends upon source plus distance, surface plus direction. Example, desk lighting level. Another for luminance, it is brightness of a screen. So thanks friends for observing this particular module silently. If you have any question, kindly ask me.